Boom! What's up, everybody? It is Andrew with Medic Made Easy, and today's video, more math. That's right, we're going to do medication bolus calculation as well as a fluid administration calculation. So stay tuned, it's a quick one for you today. So let's get right into it. Medication bolus and fluid administration. So medication bolus, we're talking about getting that medication, getting that file, and drawing out the amount of medication that you're going to administer IV push to a patient. So the equation we're going to use on that one is dose times concentration. So how much medication do we want to give times how it's packaged. On the fluid administration side, the equation we're going to use is dose, which we don't oftentimes think about in the pre-hospital setting, but think about a fluid admin dose as like we're going to give 500 milliliters of fluid over the next 45 minutes, something like that. So dose times what tubing we're going to be using, since we're going to be dripping that medication over time. So first, let's do the fluid bolus, which again, our equation that we're going to be using is dose times tubing, and that's going to give us our drops per minute. Drops, abbreviated GTT for gute, Latin for drips. So drops per minute. So the dose that we're going to use with, just pull some numbers out. Let's say we're ordered to give 1,000 milliliters of fluid over the next 2 hours. And the tubing that we're going to use is micro drip tubing. And micro drip tubing, remember, is 60 drops per milliliter. So every time 60 drops go through the little drip chamber, that's 1 milliliter of fluid going into the patient. So since we're going to get down to drops per minute, let's go ahead and convert that 2 hours in the dose over to minutes. So that's 120 minutes. Then we're going to set it up. Dose times tubing, 1,000 milliliters over 120 minutes times 60 drops per milliliter. Multiply across the top, multiply across the bottom. That's going to give us 60,000 divided by 120. Pull out your calculator, and that's going to give us 500 drops per minute. So next we're going to be doing a medication bolus, which, remember, our equation is dose times concentration. In this example, we're going to use midazolam, so our old Versed, which is packaged in 10 milligrams in 2 milliliters of fluid. Now we're going to do an equipment call out, and as you're getting your equipment ready to go, you should be thinking through your 6 rights of medication administration. So making sure that you have the right patient, the right medication, the right dose, the right route, the right time, and the right documentation. So thinking through your drug profiles, making sure you're hitting all your indications, not hitting your contraindications, checking the expiration date, all those good best practices for medication administration. So once you've checked off your 6 rights of medication administration, you've got your syringe ready to go, you've hooked up your needle, and you've got that medication vial out in front of you. We're going to take a look at it again, confirm that concentration, how it's packaged, and we're also going to double check that expiration date. And then we're going to be ready to go. Back to our math. So the dose ordered, let's say we're ordered to give 5 milligrams of Versed in this situation. So make it a fraction, 5 milligrams over 1. Dose times our concentration. And our concentration, we said we have 10 milligrams in 2 milliliters of fluid. So we're going to set that up as 2 milliliters divided by 10 milligrams. And in dimensional analysis, that's going to allow us to cancel out those milligram units and leave us just with the milliliters that we're going to want to pull out of the vial with our syringe. So multiplying across the top, 5 times 2, and multiplying across the bottom, 1 times 10, gives us 10 over 10, which is 1 milliliter of fluid. And that might have been super obvious to you. 10 milligrams and 2 milliliters, that means there's 5 and 1 milliliter, and another 5 milligrams and another milliliter to give us the 10 and 2. Now, oftentimes in pharmacology and medication administration and just the drug dosaging in general and how it's packaged, a lot of times it's pretty straightforward numbers, which is good. It's going to take out a lot of that stress in the moment, in the heat of the moment situation for you. Now, when you're ready to actually draw the medication out of the vial, the first step after we've cross-checked everything else, all our rights of medication administration, everything, is we're going to, with the needle on the syringe ready to go, we're going to withdraw the plunger on the syringe back to the amount that's going to be the amount of fluid we're going to want to draw out of the vial. So in this case, we're going to want to pull out 1 milliliter of fluid. So in order to not create a vacuum inside that vial, we're going to first inject a milliliter of air into that vial, and then we're going to be able to pull out that 1 milliliter of fluid nice and easily. And the last step, now that we've got that 1 milliliter of fluid withdrawn out of the vial, is we're going to want to make sure that we expel any extra air that's left in there. So flick on the syringe just a little bit, push that plunger ever so gently until you see fluid start to come out from the top, and you're ready to administer that medication to your patient. Now I thought I'd do one more for you, just with one extra variable. So again, it's another medication bolus, so our equation is dose times concentration. This time, however, we're going to do diltiazem or cardizem, which is packaged as 25 milligrams in 5 milliliters of fluid. And the dose that we're going to go with is 0.25 milligrams per kilogram. That's the extra variable. In this case, it's weight-based. So we need the patient's weight, which is 80 kilograms in this example. So 0.25 milligrams per kilogram times 80 kilograms is going to give us a dose of 20 milligrams that we're going to want to administer to this patient. So 20 milligrams over 1 to make it a fraction. Dose times concentration, and the concentration we're going to set up in this example is 5 milliliters over 25 milligrams. Multiplying across the top and bottom after canceling out our milligrams is going to give us 100 over 25, which is 4 milliliters of fluid. So again, taking a look back at the original concentration, 25 milligrams in 5 milliliters. That means each milliliter has 5 milligrams. So 1, 2, 3, 4 milliliters of fluid is going to have the 20 milligrams for the dose that we want to give. As always, thank you for watching. I greatly appreciate it. If you're learning this for the first time or reviewing it because it's been a long time, keep up the hard work. Let me know if you have any questions. Follow me on social media. I do a daily question of the day, literally a question every day, to just kind of further test your knowledge. So that's on Facebook, also on Instagram. And keep me posted on how it's going. I would love to hear from you. Thank you.